start. Sorry for being late. So, my name is Matteo Porta. I'm a project engineer, mechanical engineer in Marina Consulting, and today I'm going to share this session regarding the topic building flexible energy communities, and specifically remuneration, aggregation, and market interfaces. I'm the coordinator of the STAN project, and I'm going to tell you something about the project. And we are here also to talk about this project that you can see here: Masterpiece, Fedecom, Neon, Energenius, Independent, Interpret, and Ibusco. And I would like also to mention my colleagues that are going to present all of this project. Fayaz from Art1 for Masterpiece, Zia again from Art1 for Fedecom, Fausto San for Neon, Pablo for Energenius, Arso Savanovic for Independent, Raymond Sterling for Interpret, Ana Garcia Garre for Ibusco. And then we will have this open discussion at the end of this session. So before to start, I would like to briefly introduce the topic. So we are basically here and to discuss and to present our first insights from the project related to flexibility, and flexibility in particular related to energy communities. So you can say that flexibility is a trend topic because it's a topic that is quite popular recently due to the introduction at European level with different level of progress for each member state of local flexibility market that are basically managed by local DSO, so distribution system operator. And this is something that in particular is related to the development of energy communities. Since energy communities that can consider both in industrial and residential sectors and end users have the possibility to participate in these flexibility markets. But the participation in flexibility markets, as you may know, is not an easy task because it requires rules, it requires knowledge, it requires technologies, and it requires investments. And in all of the projects that we are going to discuss today and to present to you, we are addressing at some point all these aspects. And what else? Yeah, I was mentioning before that in each member state the level of development is different because in some countries the local flexibility market are already established and they are already operating. So the end users, whether they are industrial operators, industrial end users, or residential end users, they can enter the markets. But of course, it's not, as I said, it's not easy. Specifically, when we are talking about residential end users that have not probably the capabilities in terms also of capacity. And so for this reason, that is that the reason why then became important, for example, roles like aggregators or balanced responsible parties. And this is something that it is important to understand how to also include in this ecosystem also these new stakeholders that can play an important role. So this to introduce the topic. Um, we would like to then tell you about some results and key findings from all the projects that I mentioned before. And I will start. I will start with the project that we are coordinating. That is the stand project, and this project is at month 12 of development, and you can see here the main objective of the project. We would like to develop and demonstrate an hardware software solution for the optimal management of complex energy system in industrial site and residential buildings. This is exactly what I have introduced before. So the main focus of this project is to provide an orchestration systems in terms of algorithms that can manage the complexity of such type of ecosystem, and in particular an aggregation of end users, both industrial and residential, in order to then provide to the external markets the possibility to play with flexibility. And this is our first objective. Here you can see the list of participants. We have a demonstration site that is managed by Abba. Then we have Energy Pool and SEA that are providing all the cluster knowledge for the French country. Then we have another demonstration site in Spain, and there is an ecosystem of partners that comes from Spain. So Cuerva, Helio Cloud, the Ulster University, and MIW Energia, and New Concisa, that is the partner that is hosting the demonstration. Then we have another pilot in Italy that is basically managed by Engreen, a small enterprise that is based in Puglia, where the the demo sites are placed, Carapa and Normal. And together with us and with R2M, that is basically dealing with the bridge what concern the bridge initiative. We are coordinating the Italian ecosystem. And then we have Arcelic that is providing some IoT solutions, the Istituto Nicolo Pupin, and also Staying that is dealing with communication um, and dissemination. This is the conceptual scheme that we are proposing in the STAND project. We are providing this multi-level orchestration system that is based on an IoT and cloud platform to provide some flexibility services, and that are addressing some key points while we are connecting with the markets. So price signals, balancing and frequency services, smart charging, demand response, congestion management, and flexible production. This is done via a user interface, graphical user interface, to connect with the DSO and the signals coming from the external physical grids. We are considering the building layer, so building, residential building and industry. And of course, we are connected with the market in order to acquire flexibility and flexibility prices and energy prices. Now to address the operational complexity. So the operational complexity is one of the key points when we talk about flexibility, because flexibility, of course, is something that we need to predict in advance in order to play in the day-ahead and the intraday markets. And this is something that could be a big constraint for the end users, because to predict flexibility, of course, is not an easy task. It depends on the loads that are considered in the demo sites and the buildings, and in order then to decide when and how much energy to consume, it's something related to load optimization, but flexibility is something that is going to change the behavior of the end users inside. And so we need to balance in the optimization routines and the and the algorithms these two aspects. And instead, we have this multi-level approach, and what we need to ensure that the flexibility that is provided by the load is then achievable whenever the flexibility signals is acquired by the DSO, that is not in principle predictable a priori. And so this is one of the key challenges that we are addressing in the STAND project. And we are doing so using this method that is called bilateral Stackenberg game optimization method, that is addressing the complexity, dividing the system into main layers. The layer of the aggregator and the layer of the buildings. We are proposing three different configurations: the centralized, decentralized, and the distributed configuration. We are proposing, of course, an hardware software solution, because to make this happen, we need both hardware and softwares. And of course, we are addressing the main actors of an energy communities: aggregators, consumers, producers, and prosumers. We are going to control the single assets within each building, or in alternative, in the decentralized configuration, we are communicating with single BMS that internally are managing with their specific rules the complexity of each building, and then the aggregator has the role of interfacing the lower layer with the signals coming from the market. Then how we are going to enabling the digital and physical infrastructure. We are going to enable this with the development of a software solution that is provided by Iliad Cloud, the Spanish company. And we have several steps. We are developing the standard cloud platform with a user interface. We are, of course, connecting with the site with the establishment of some agents that could establish a dialogue with the single assets and with the broker that is at the standard cloud platform. And of course, this is the hub that is represented or by the single buildings or by the energy community as a whole. And in this platform also will host the models and algorithms that then could manage the complexity using the bilevel Stackenberg optimization method. Then the last point that we would like to address is governance and contractual innovation. This is again not topic to address, because of course when it comes to the agreement between the single members of an energy community and the aggregator, between each of the building and of the with respect to DSOs and TSOs, to have a clear picture of how the contract could make happen this ecosystem is important. And so what we are doing in the first 12 months of the project is have an idea of which type of contract should be established in order to put in place this solution. And contracts that need a clear and balanced agreement between all the parties, contracts that should define a sort of common agreement with the standard templates, and of course clear remuneration schemes. And because of course bonuses and penalties are foreseen when the flexibility is activated or not. And of course, this should come from the regulatory system in order to provide clear rules. Of course, the governance of related to contracts should ensure transparency, should ensure clarity and discriminatory conditions for all the actors. And of course, this is an innovation project. We are addressing this complexity from all the perspectives, and this of the contracts still remain a very critical point to be addressed and to be solved, because we are talking about the real end users that are living on the buildings and operating on the buildings. Of course, there are many opportunities because this type of solution allows to have more opportunities from both end user side and DSOs and TSO side in order to balance the electrical grid. The next steps, of course, we are still in the preliminary phase of the project, so we are going to finalize the models and the algorithms. We are setting up the algorithm software framework, and we have the detailed design for the standard solution. We are working on this, and of course, then there will be the implementation phase. So then I leave the floor to the next project. Antoine.
Yeah, thank you, Matteo, for a very nice and detailed presentation. And I think it's really true that Stand is trying to tackle the problem of flexibility in a very comprehensive way. So that's why we had this detailed presentation about flexibility management in an energy community. Now I'm going to share a little bit different perspective on energy communities, because with the masterpiece, the main focus is not just on the flexibility, but supporting energy communities throughout the whole life cycle of energy communities, starting from some people coming up with the idea that they want to start an energy community, all the way to the design, planning, management, and their integration in the electricity markets. So the mission of Masterpiece is to create this modular platform of tools and services that support energy communities with this life cycle. And how we do it is there's also a strong focus on the social innovations and participatory processes. And then we also have these ICT tools that somehow support on this life cycle journey. Yeah, Masterpiece is a Horizon Europe project. We are around month 33. So it's in the last stages. The coordinator of Masterpiece is University of Murcia, and so they are not attending sustainable places. So I'm presenting on their behalf. Our role, R2M role in the project is we are also developing some tools, a mobile application for engagement, and also a capacity building tool. But mainly the exploitation and business models in the project. Yeah, just to focus on the one aspect that the focus of Masterpiece is not only on just one aspect, but supporting energy communities with the whole life cycle. Because of the topic of the workshop, we are going to focus on one tool of Masterpiece that is the DR Flex, that is tool for managing flexibility in an energy community. And just saying, yeah, so we are in the last stages of project. All the tools are available to pilots, and we are doing validation activities. And you can see there's because I said there's a lot of tools and services that support this life cycle. So how Masterpiece has enabled these all tools to share data, access data, is through following some interoperability standards like NGSI, LD data models, and common data models, so that all these tools somehow are able to talk to each other and then support with the activity. And yeah, we have 3 groups like simulation, EC management. There's also a group related to discovery, awareness, enrollment. And then there's this 3rd group, which is flexibility, DR, demand optimization. So now I would focus more on this DR Flex, which is a tool for managing flexibility in an energy community. Yeah. So now just sticking to the format of the workshop as we discussed when we were discussing about the workshop, that we focus on these 3 pillars of managing flexibility in an energy community: the operational complexity that is related to activating this flexibility. So for this part, yeah, we're using approach of forecasting and optimization. In the next slide, we go a bit more detail, like what methods we are using in order to forecast and optimization. And then, yeah, and both of these options are possible with the Masterpiece DR Flex tool, that you're also able to automatically control the loads in cases where it's possible. But there's also a possibility through the DR Flex dashboard that you can get notifications to users who don't support the automated control functionality. And on the second part, honestly, we are not focusing so much on this part, but we have some things that somehow fit into this pillar of contractual innovation. I don't know if you know about this USEF. It's a universal smart energy framework that tries to standardize the flexibility request and the interactions between aggregator and system operators for flexibility trading. So Masterpiece is compliance with this framework of this standardized flexibility request between these 2 different actors. And also we are integrated with ENSOI electricity prices that allows to also take into account these implicit signals for the optimization. And yeah, we are also performing a study to explore, like a theoretical study that explore flexibility markets within an energy community. And the pillar 3 about the digital and physical infrastructure. As I said, it's one of the main complexity of putting all this data together. So we are trying to solve this problem by relying on interoperability standards like NGSI implemented by Fiverr. Yeah, so just going a little bit more detail about these pillars. I think, yeah, for forecasting, we're using some neural networks and machine learning technologies to forecast. And it's not just forecasting the generation and forecasting the demand, but also you're able to forecast the flexibility bound and then, yeah, a lower bound and upper bound. And then there is the optimization that takes it into account, these bounds, in order to come up with the optimized curves. And for optimization, we are using reinforcement AI-based technologies. And as I said, there's this possibility that you're able to directly control loads wherever it's possible, but otherwise, there's also through the dashboard, through the user interface, it's also possible to provide notifications and recommendations in case this automatic control functionality is not available. And yeah, on the second pillar, we are currently doing some, because we didn't focus so much on the peer-to-peer and other trading local energy market models, but we are going through performing a study that explores the implementation of flexibility in markets within an energy community. And yeah, so we comply with for the explicit, because as I said, DRFlex is able to take into account the explicit and implicit signals in order to do the optimization and activation of flexibility. So we comply with USEF protocol, and also ENSOI. We have integrated the market masterpiece solution with the ENSOI market prices that that support this trust and engagement. And I think, yeah, on the pillar 3, one of the main challenges that we faced is just bringing all the data from different pilots, different countries in different formats, and we try to solve this problem by relying on common data models and interoperability standards like NGSI. And because somehow we comply with this standard, that also makes the solution of masterpiece platform or DRFlex also applicable to other domains like cities, industries, stuff. Yeah, on the impact side, yeah, so it's mainly on the optimization activation. It's the reliable integration of flexibility services within the to improve the grid stability, and also cost savings for energy community members. On the fair market second pillar, I think yeah, compliance with this USEF and ENSOI market prices yeah, increase adoption of this transparent and fair framework enhances stakeholder and trust and engagement. And the third player on this hardware and software infrastructure that enables flexibility. I think, yeah, because the compliance with these interoperability standard makes our solutions interoperable with also other domains. On the next steps, as I said, we are in the final stages. We are doing validation activities of our tools, including DRFlex tool that is for managing flexibility. We have 8 pilot sites in 5 different countries. So now we are in the second stage of validation. In the first stage, we validated our tools with the pilot community managers, but in the second stage, which we are currently, we are testing our tools also with the community members. And then also, I told you about this study that we are performing about flexibility market study. We also finalizing the study of exploring flexibility markets within energy community, and would share the result in upcoming months. Thank you.
Should close.
Yes, it's the last slide.
Okay.
Yes.
Thank you.
Hello, everybody. So for the 3 pillars, the in bold is what relates to FEDECOM. I think you forgot to remove the bold part because we agreed on these 3 as the 3 pillars. So for FEDECOM, the operational complexity lies in the optimization and activation of the technology. So the technology aims to trade energy both within communities and amongst different communities. So there's two ways that we're doing that. The peer-to-peer is within one community trading, and then between different communities, we're using peer-to-pool or peer-to-market, where the bids get combined into one pool and then traded using automation with other communities. So the governance and contractual difficulty lies in the remuneration and the fair, rewards and penalties for the different trades. And then the digital and physical infrastructure is dealing with enabling the federation, so linking one community with another. So the technology that they are developing is mainly open source. It's modular tools and services. The open source model is GPL version 3. And a lot of it is dealing with sector coupling. So the pilots there are 6 use cases in 3 countries. In Spain, there's 4 different use cases, one in Switzerland and one in Belgium. And so these are the different vectors that they're dealing with: electric vehicles, hydropower, hydrogen, and so on. So for the main results, the operational side, they're trading on a 15-minute basis, monitoring the self-consumption and peak shaving. For the cross-border federation, there's actually a change. It was with Belgium and Netherlands, but now it's the different regions in Belgium because of an administrative issue. The governance and contractual side, the main issue is so grid singularity has this decentralized energy exchange, which is the main technology. It's a blockchain-based platform. And so all of the trades are being tested through this software. And for the infrastructure side, the security is enabled by verification through on-chain and off-chain models. And then the pilots are, as I said, very diverse. There's 6 different use cases. So it's difficult to, enable all of the different hardware and software in those pilots. And then the main impact on the operational side is the improved renewables hosting and enhanced flexibility with the trades. On the governance and contractual side, they're aiming to build trust with the remuneration models and provide governance for replicating the community models. And then on the infrastructure side, the open source model is one of the main innovations, because a lot of the technologies for energy communities are not open source. So proving that in the demonstrations is one of the main purposes of the project. And then moving forward, we're at 136. Originally, it was going to be 48 months, but then we're going to have a 1-year extension. And they will work on green certification and integrating the forecasts, finish rolling out the pilots with the remuneration models, and then figure out how to disseminate the open source components for replicating the models across Europe.
Thank you, Sir. The scheme of the workshop is to have all the presentation and at the end the session of question and answer. But I would leave the floor to Fausto for NEOM project, and then I will maybe stop and collect your questions if you have for the first 4 projects, and then move forward with the remaining 4. So please, Fausto.
Thank you, Matteo. Right. So 2 questions before I start.
No.
Okay, good. Right. Neon finished last year in May. Okay, so part of there will not be next steps, obviously, but you will get some of the insights from the project that was finished last year. I must also say that, well, first of all, I'm Fausto Sainz, sorry, from Comet. This is a small company based in Barcelona, and we basically do the communication, dissemination, and some, in my case, some software help with doing UX. You talked before about user interfaces, so we'll also do that in case you have to develop some sort of application to do the control, the management, etc., as we've done in other projects. So, yeah, now finished last year. And another thing I need to say before I start is at the beginning, we have 4 pilots. And if we have time, I'll let this issue with the 3rd pilot at the very end, because one of the pilots dropped after 1.5 to 2 years, just when I took over from the project. So I'm not the project coordinator, I was just a communication manager, okay? So bear that in mind. So the idea was, again, setting up any communities. It is true that in the case of Las Cabezas, it was the 3 remaining pilots were Las Cabezas in Spain. That was a hybrid, let's say, pilot, because they have an industrial site together with a part of the village nearby, where they get the grid and the connection and the community at the end. I don't know whether, at the time of the project in Spain, the regulation of this energy coming and going, demand response, etc., was not set up. I don't know the situation in other countries. That regulation has to be going on, so sometimes you can get an impact to it, but at that point, it was not possible. Also, there is also business issues that in actual you know about. So, but that pilot site managed to get the energy community working. The Berkida pilot site was here in Italy, had already set up the energy community, so it did work fine, perfectly fine. And the same city, the one in Paris, was also working. And this was more, that was only industrial site, okay? So the idea of Neon, as it says, is exploit the building energy efficiency, renewable energy generation, and storage, and demand flexibility. We did set up V8 charging, for example, in the case of Las Cabezas. So this led supposedly to increase energy savings, reduce CO2 emissions, and provide cost savings across sectors. The services provided by the Neon project was energy efficient services for multi-measure buildings, building efficiency improvement, optimal energy assets and scheduling, the advanced building control for optimal operation of heating and cooling system, lighting, smart appliances, etc., etc. In this case, for example, we did have a lot of interactions with the people from, especially from the drains, from Berkida and the Las Cabezas village people. So we tried to teach them or encourage them to use energy when it was most suitable for the system. Okay, this is in connection with the demand response approach that it was set up in Neon, and also tailored service to ensure comfort, health, etc., etc. You cannot pretend for users to sacrifice themselves in order to get the system working better. So you have to manage this, and it's not, sometimes it's not so easy. So as a project overview, following the pattern from previous projects, as I say, well, the optimization activation had a holistic optimization approach, because we wanted to have, as I say, not just taking the technical issues into consideration, but also the user, the consumer, etc., etc. So we have the advanced scheduling and optimization of energy assets. This was developed by Michal Pupin. And then we take into consideration the building performance. So we did a multi-measure retrofit planning in case some of the old dwellings, houses needs to improve part of the places, but not only the houses. For example, the installation of the VHC chargers in the outside the GFIET photovoltaic place. Digital control systems, as I said, there's some applications for them to control what is going on with energy, and performance monitoring. Regarding demand response, this is also, well, it's very important. Hybrid demand response models, grid flexibility enable. So although we tell them this is how you should be using follow the applications or the advice you give you at certain times. As I say, you enable it, but this is up to the consumer and prosumer sometimes. And then the load management optimization. In case of the fair market participation, well, we did energy performance contracting. As I said, the question at the time, it was very difficult in Spain because the legislation, the normative was not very clear and it was starting up. I don't know who knows about how it's going on nowadays. I know it has improved, but it was there and it was starting to be going on. Maybe perhaps you know how it is going nowadays, but I'll let the project
Still not so clear. Has improved, but it's still like not very clear how to differentiate from this collective plant. Now it's 2 kilometers to what a real energy community is.
Yeah, it is. It is still going on. 3 minutes. Okay, good. I will be very quick. So the financial structure, again, this is related to the legal framework. So, and also you have to sometimes get hold of some sort of government and the layers of administrative helps you can get. And a cost-benefit analysis was done by a trend. Then enable federation, well, and again, open market platform, security and transparency, blockchain, data security, etc. So users were confident or comfortable with other users in the same place, knowing certain data from the usage of energy. And we did have a community engagement system. Again, this is important for especially citizens to get. Because we're going to publish a paper regarding this. I'm going to be very quick about it. Because some people think that these citizens, we know because we are in this, but most citizens do not know anything about grid, in and out, or all these sort of things. So you first need to teach them or show them what are the possibilities. This takes into consideration the legal framework. So not so easy. So the results, it was the holistic assessment scheduling framework. As I say, it did work. The hybrid demand response model is deployed in the 3 pilots. And then the smart grid data integration. For the market, we have the multi-actor APC models defined, the legal and financial frameworks. This was starting. We try to help, to feed into the administration on what could be done. And the co-creation methodology, this was done especially with the areas. The federation, again, it was with the blockchain, the smart contract automation, the incentive ranking system, and the performance protocols. And the impact at the end, this is, well, the framework for the CSC, the energy communities. As I said, it was quite, it was already set up, so it continues, it was very good, but it was brilliant in the case of Las Cabezas, considering it was a hybrid system with an industrial part and some of the inhabitants of the village. So, and now it's set up and it's working after the project finished. So it was like 6 months that I found out that they did it. So NEON has the ground for next generation integrated service, empowering citizen energy communities, which is, as I said, something that Europe is trying to encourage, and to participate actively in the market. Again, this is very much related to the fact that we need to know how the legal framework is going to work. And in the long term, well, the idea will be to scale up the model, because these were relatively small communities, replicate around sectors, and foundation for future innovation. As I say, this finished May last year.
Thank you. Okay, because before to go ahead, I would like to stop here, maybe to collect some questions from the audience, if you have any, about this project that we have presented so far. So please don't be shy.
Mateo, okay, I got a question for the project. In which state you are? Because you know that NEON just finished, and it's good to know, and maybe we can ask about lesson learned, but for the other project, I didn't get in what stage they are. Maybe they're finishing, or maybe they are starting to implement the solution. I think that could be
In
nice.
STAN project, we are at month 10. We are at month 10 and we are in the design phase of the
Well,
solution.
actually, for you, I know. But yeah, it's good to mention.
He was the only one.
Well, I mentioned, you mentioned
yeah.
it, for Fedicom, it's month 36
So
of
you're
40.
finished. Well, you got an extra year.
Yeah, so
Sixty.
originally it was 48, but now it'll be 56.
Have you started
Or
for the,
60.
with the demonstration and so on?
Yeah, they've rolled out all of the demonstrations, all of the use cases, and now they're integrating the software into the hardware. The first year or two of most projects, it's, launching the hardware of the pilots, and then once the software gets developed, then you integrate that in.
Sure.
So,
Yeah, also for masterpiece, it's the last 6 months. Project is ending in June, and I think I already said that we are going to the second validation phase. So first, we did it only with the pilot representatives, and now it's more with the members of the communities. So yeah, we are in the second iteration of validation activities in masterpiece.
Thank you.
Also, yeah, I think I have a question that we can now or later discuss, because this trade-off related to activating flexibility, because you have a comfort, you have cost, you have energy. I think, yeah, it's a lot of optimization approach they need to take into account. But you think there could be something more interesting that does evaluate these trade-offs more in a real-time way while activating flexibility. So instead of having more like static, that okay, this is for temperature and this is for the cost, but somehow evaluate these trade-off on a case-to-case basis, and then you make decision about flexibility through this.
You're asking to STAN project?
Yeah, also
Or in
stand in general, because now we're talking about managing flexibility, and I think it's also the main challenge, because I also heard in some other workshop developing algorithm that is able to look at these trade-off and then come up with some result that allows you to activate flexibility in real time.
This is quite interesting because from what I know, there are several perspectives and several ways to solve this issue. For example, in STAND, the idea is to use probabilistic models in order to have the probability value of certain in this case, that the availability that you have bid into the day-ahead market, then it becomes real, because then the activation signals is sent to you. So it's since you are not sure about when this activation signal will come. So we are thinking to use, because we are still in the design phase, probabilistic models in order to have this probability, and according to this probability, then to try to find this trade-off in order to balance revenues and penalties, rewards and penalties. It's a matter of probability. But there are other approaches, like the ones that we heard this in another workshop, that use reinforced learning in order to act almost live, so in real time, when the signal comes. This approach should act instantaneously, in real time. Two different approaches that are addressing a very different way this point.
Thank you.
Other questions? Maybe you have a
No,
question?
before we move on, I think next one is Energinius, yes? The next project.
Yes, next
I
project.
would like to shake a little bit to wake us up. I would like the last line to come a little bit forward because we need to pass. We need to pass the corridor. Please come to the front or find another place. Sorry for that request. It is for the special reason.
You will see it later.
Yes, it's a surprise. I prepare the ground. I start prepare the ground. Are you gonna done? So get moved.
Yeah.
Well, I say. Well,
So the
doing
the first
innovation,
row of
yes. I'm not trying to do boring things. I haven't got my ideas. Sorry for that. Terribly sorry for that.
No, you are not.
You don't seem to be sorry. You seem to be enjoying it.
Yeah.
He's always enjoying his life.
Yes.
And I have a question for Zia, for Fedeco, about the energy communities, how they can activate flexibility more than traditional demand response schemes.
That's the question. That's the question I suggested. No, I think it was more general for other projects. But my point of that is, you know, why are energy communities, if, when I first started in energy projects, it was demand response was the main topic. And demand response, in my opinion, didn't really find any uptake because it was a very centralized model. You know, the utilities had to kind of step in and you know, operate your equipment for you, and people didn't really want that. So my point of that question is, why are energy communities better than demand response to activate flexibility? And in my opinion, it's because there's, you know, asset ownership. You know, when you have energy communities, even if the asset's not in your building, you're a part owner of it, and so it gives you responsibility over it, and it gives you incentive to take part and change your behavior in activating that flexibility, and even incentivize you to take part. But also automation is a big part of it, because demand response, it was hard to be it wasn't really being automated in the same way that energy communities are. But that question was mainly for all of the projects, not for FEDECOM. And FEDECOM were trading energy and flexibility. So it's, you know, they're treated a bit differently. But yeah, that was to see the other approaches of the project.
So I think I agree, especially about this ownership thing. I think it's a main factor. But the other thing is just the composition of energy communities, that you have generation and you have consumption at the same place. So also just collective self-consumption, and this it just make it more suitable model to leverage also flexibility for local consumption.
It's my opinion is that energy communities enable the possibility to apply to this scheme of demand responses, and particularly explicit demand response when it comes to playing on the markets, on the local markets, the day ahead or the intraday. If you are a single user, a single building, say, you cannot participate. But if you belong to a community and the community are aggregated by an aggregator or a balanced responsible party, then you are not only have the possibility, but you are allowed to from the rules of the market. And so this is what I see to answer to this question. Now,
And even energy communities can act as the BRP or the aggregator. You know, with the technology, it kind of almost it kind of takes the role away, in a sense, of the aggregator. So before energy communities, you needed an aggregator, and now with the energy communities, it can be the aggregator. At least that's what Fedicom is trying to do with the technology, is remove the need for an aggregator or a balanced responsible party.
Yeah, but again, there's a bit of a ambiguity due to different regulations in different countries. For example, in Slovenia, where I'm from, I can be my own energy community. So if I have a residential house where I live, I have photovoltaics on there, and I have a summer house somewhere else. I can use the production of my photovoltaics. If I cannot use it locally in my residential house, I can use it in my summer house.
But directly.
So, you mean what?
Virtually.
But I mean, for
Virtual, of course.
Virtually, but I mean,
of course, you have to use the
you
grid.
have a-
You cannot.
that's like a net metering or
Well, metering is being phased out in Slovenia. So,
Net billing.
net billing.
yeah. But what I'm trying to say in that case, it's very hard to talk about energy community being able to act directly in the energy market because I'm too small still. I'm still too small.
You're quite right, because very often, in my opinion, we are confusing the energy community concept with the flexibility market concept. Because at least in Italy, the energy community started in order to increase the self-consumption from renewables.
In local areas.
Locally.
Yeah. So that's what
This
you're
is-
talking about. But here, in our case, this is not local at all. Okay, and I can also have my neighbors. They have a summer house somewhere else, and we can share productions
So,
in residential houses.
At some point, we are mixing up two different things that could stay together, of course. So being energy communities allows you, better than not being in the energy communities, to play on the flexibility markets, local flexibility markets that are established.
But this discussion just shows this is still a developing area. So we even have problems with the terminology.
No, yeah. Also, for
Yeah, yeah,
instance,
yeah.
in Italy, so we also have, there's also a model which is just this, that at distance. So this consumption and production can be at a distance.
Yeah.
And then it's not an energy community, but it's a call like individual self-consumption at distance. So there's a model, but
So it's a different model, because if you have a local energy community, you can actually operate in an island mode almost. So you optimize locally, not to burden the grid, and then if you have overcapacity, then you can share it.
Yeah, also in the case of Fedicom, the technology is more advanced than the regulations. So the regulations need to catch up with the technology.
But that's more of a rule than an exception, right?
Yeah,
Technological fields.
exactly.
Do you have any other questions on the topic or in general? Because otherwise we can move on with the other
I think we
presentation.
should
We are.
Yes, yes.
Really?
No, because we are already taking some time for the
last
section.
section, the last one.
Then we can move to Genius.
Okay.
Genius.
Yeah. So to stay in time, you should have 8 minutes.
8 minutes. Okay, and the one more restricted.
We need a little bit more, you need 20 minutes, so I will
Okay.
take 10 minutes on this, yes?
I'm Pablo Barrachina, project manager at Voltiva Energy, formerly known as MIW Energia, and I'm the project coordinator of Energinis. Okay, before starting the presentation, I'm going to ask my colleague Raul Tomar from Digital Twin Technology to start with his show. Okay?
So like basically, I'm going to scan this room. So this is one of the approvals of this project. I'll give you the result after scanning it by the time he's presenting.
Okay, now I can proceed. Okay, our project is a little bit different, so that's why we focus on pillar 3, like the digital tools we are developing. Okay, Energinis, smart energy solutions for a better tomorrow, try to have this multidisciplinary approach that try to blend and mix cutting-edge digital tools, a symbiotic ecosystem, an innovative engagement method, and a secure, obviously, interoperable, scalable framework. Okay, what we have is this ecosystem. We have some data entering through and digested to our project, to our solution, from different fields, not only energy, I will comment later. And we have, for this part, that is like the digital tools, all the solutions for the user. We have the community. In that sense, the community is broader for all the users in the Energy and all the stakeholders. And we have the marketplace. There, the community can share their learn. They get more knowledge about energy and the other sectors, and we have this crowdsourcing. Okay, we will present the tools later. And in the marketplace, okay, the users and stakeholders can get products, services in exchange of tokens, the Energy coins we are creating, but also it's like the entrance for all the stakeholders that want to offer some products and services. For instance, flexibility. Okay, a retailer can get to the marketplace, offer some rewards for the flexibility of the users, and the user can get these services. So let's continue. So as I said before, the idea in this project is not staying only in the energy field, but going beyond. We have a total of 9, so 8 extra cross-sectoral data spaces. So we got, for instance, data from tourism, data from health and nutrition, data from urban mobility, from social media insight that we are trying to get to improve and enhance our solution. So this is the main part regarding the digital tools. What we want to provide to the user is a one-stop shop, a digital platform, in which he can find different tools. These are the main ones. I'm going to show you one of them. Okay. So this is loading. Okay. One of the tools is the scan to the T. What is Raul is doing is scanning in the room and the user premises.
Yes, I'm watching.
The second one is the end play. With this series game, the user can play. I don't know if you remember the Sim games. They can simulate different action. They can have these challenges, so they can test their energy knowledge. They can increase their energy literacy. And the good thing is that they are playing on their own premises thanks to the scan to the T.
That is the most important part. Usually in the video game happens that we develop a static house and everyone has to play in their own, not in their own apartment, somebody else's. So this is why we developed this app so that you can scan your apartment, your energy equipment, everything, and then play in this game. So we export the output of that.
And this is what Costa is showing. And moreover, we enhance this framework and this play with the Guru. Guru is our AI recommendation agent. It's like a chat box that you could ask any energy-related question. Also, we are increasing to have the other cross-sectoral data sectors, and they provide answers to the users. But also, the Guru, please, Costa. Later, we didn't have the dinner to explain. So they got this Guru that also try to analyze and try to provide this return of investment of the solution.
Seems to be impressed.
Yeah.
It is,
We should-
I'm pretty
Okay,
impressed because
finish
you had a problem here
So-
with this one, it's not a wall. And already, it is here, the window.
Okay, let's continue. We got the panorama, this is an analytic dashboard. We get also some information, analytics, comparison with peers, and we got the Echo Pulse. That is our wearable and our smart watch that provides health information, and also it provides also dietary recommendation, and it's connected with the rest of the solution to get the notifications. So as we are at month 14, we don't have any results but we plan to implement the solution in 10 pilot sites with a clear methodology. We have the leaders, then we got the learners that get experience from them, and finally the listeners for scalability and try to plan the possible exploitation. We have the goal to reach 2,000 stakeholders between users and active users and passive users. We have the target to have 200 scans to DT. Hopefully you will do it at your own home. And we plan to do several cross-sectoral businesses, servitization, and obviously implement flexibility services. As I explained, this is a way that retailers can offer to the users. Yeah, this is the last one. Well, almost the last one. Okay, so we are at month 14. What we have done right now is like getting the user needs, the use case elicitation, and the architecture blueprint. So we have just finished that, and we are starting with the first development sprint for these tools. We plan to, at month 18, provide the users with this beta version. Then we have the first demonstration phase. We have the preparation of the leaders, focusing on the leaders, the first pilot. Then we get the feedback from them to increase and improve the tools and start with the service integration. Then we have the second demonstration phase that goes from leaders to listeners. And the final and third development sprint is from month 29 to month 32, that they would do the final refinement of the solution. This part of the demonstration phase goes through all the pilots. Finally, they goes to the listeners, and we are trying to, get the final validation and trying to get the business models and how to exploit our solution. But before you leave, otherwise Costas is gonna kick your asses. So please scan this and follow that.
Let me tell you something. For all of our LinkedIn users, followers, we are going to give the Raul's application. It will be always for free to give us our feedback. So you can try the application anonymized, fully anonymized at your home. So try to follow us on LinkedIn, and soon Raul will upload the file to
both of the versions for Android and for
I want to see all phones. Come on.
Yes.
I told you, you don't leave the room without scanning. I'm already following. Okay, that's all from my side.
And I'm not producing this based on for free.
Yes. So I'm here to present in a few short words what we are doing in Independent. So I'm following this, let's say, template that we used. Regarding the what the project is about, what we actually started with is trying to identify some important obstacles for greater uptake of renewable energy resources, and we came up with 3. Fortunately, at least the reviewers agreed with us, so we got the funding, which is good. But on a serious note, we really believe that these are obstacles for larger uptake. So the first problem, and we are trying to the answer to the problems or remove these obstacles, or at least minimize them. The first of them is that the renewable resources have very volatile nature. So when there is a low share of renewable resources, it's not that hard to accommodate them. But when you have a large share of renewable resources, then it becomes a huge problem. We, for example, in Slovenian DSOs, they reported already almost 10 years ago that they had some segments of the network which already had more than 50% of renewables, and there were all sorts of problems there. Okay, so the thing here is that if we are trying to integrate renewables or even replace the old fossil fuels sources of energies with renewables, then we have to adhere to, let's say, the rules of the play, which means that the renewables have to be, let's say, deterministic in the sense. So the problem here is how to match their inherent volatile nature with the requirements of the markets. Okay, and for this, a very important aspect is to have accurate and robust models of energy resources. Accuracy means that they are as specific and capturing as accurately as possible the future behavior of both renewable resources and also consumers, energy loads. And they also have to be adaptive, because we all know that load profiles are very similar to each other in every country, but the devil's in the details. So if you have to want to operate in the markets, then you have to accommodate for the devil in the details as well. Then for the second pillar, regarding the governance and contractual, what we are striving for example, contrary to what Fedecom is doing, they are addressing the specific market, what is called singularity, energy singularity or something like GSI, as you mentioned it. So it's
singularity.
Yeah,
It's a company.
Oh, okay. But it's also dealing with flexibility markets in regular energy and flexibility markets, or do they try to develop a dedicated market for flexibility?
Yeah, no, they're trading both energy and flexibility, either within a community or among separate communities.
Okay, okay. So what we are trying to do here, we are not addressing community per se, although in some pilots we do have communities in there. For example, an apartment building is actually a community in itself, okay? And it is managed by the building management system or energy management system in the buildings. So you are not dealing directly with single households within the apartment building, but you are dealing with the whole building, okay? So what we are trying to do here is to bring this, let's say, mostly residential, small energy consumers and producers into the market. That's one aspect. But what we find important here is to optimize the control of flexibility at all the levels. So we have a hierarchical platform or application, and we are doing the optimization at all the levels, at single asset level, at customer energy manager level, and also at the aggregator level. This brings benefits. For example, my background is computer communications and security. And there also we have, for example, security mechanisms at all different levels of the communications hierarchy, okay, in order to get the best possible results. So this is one thing we are trying to do here. And the other thing, what we are trying to do here is to have what we call transparent aggregation in multi-market bidding settings, is that we are trying to optimize optimize the control of flexibility in multi-market settings, which means that we are trying to do multi-parameter optimization. So we are trying to break the silo between different markets, between different players in the market, and try to do the optimization considering all the markets. And then the third pillar about the digital and physical infrastructure, we find the problem we are addressing here is twofold. One thing is that deploying systems, so deploying system for manager in control of flexible assets needs to be very simple and intuitive and easy to do in the market. So what we are trying to do is to develop a modular platform. I would not call it just a platform, but also a meta platform, in the sense that we integrate also the tools for the whole life cycle of the, let's say, one deployed system or one instantiation of the system, meaning that there are tools which are dealing with energy monitoring, energy optimization, and sales in the markets. But also there are tools, which is part of this meta platform, which enable a relatively simple parameterization, adaptation, and also deployment and management through operation phases. Okay? Yeah. And the second thing is, of course, we cannot do the rip and replace approach because it's too costly and too complex. So we have to accommodate for the legacy systems. And this is what we do by trying to integrate legacy systems. We are in the month 12 of the project, so currently we only have relatively early results. And what I can say about the operation complexity, what we are trying to achieve is to develop this platform in line with the most important standards in the field that we accommodate. These are the EN 491-2 12-2 and ISC 62746-4, and of course also the serif ontology, especially using, let's say, automated means for wrapping or defining serif ontologies for legacy systems. For the robustness and accuracy of assets, forecasts of energy consumption and production in the future, we are employing the, let's say, very popular or novel machine learning model, which is called neural differential equations, which is basically a hybrid model, but next generation of hybrid models, which combines physics models of the system, which is based on differential equations, which take into account the volatile nature of the system. So it is constantly changing. So we have to take into account this built into the system, not just planning and designing the system with some model on hand and then keep it fixed. In the governance and contractual, as I mentioned, we are trying to optimize the bidding in multi-market settings to maximize the benefits for everybody from the flexibility which can be used, and also to facilitate cooperation between DSOs and DSOs, which is relatively limited, especially because they have different markets which are devoted to them. And regarding the digital infrastructure, as I said, one of the most important aspects is wide interoperability, because we adhere to the standards, and also this meta platform, which means that we have the complete DevSecOps tool set integrated with the platform for everybody which wants to adapt the platform for their needs. And the final slide. So what we expect or hope to achieve with this project after the end, of course, like everybody else, we want to drive the large-scale uptake of renewable resources, but at the same time manage the stability of the grid system. So these two can be contradictory. So we need to be very careful to achieve this. Regarding the fair market participation, we hope to be able to demonstrate a wide variety of flexibility services in basically all the markets that are available. Wholesale energy markets, TSO, reserve and balancing markets, and also DSO flexibility markets. And of course, one of the key aspects of this project, because this is an innovation action, we want to demonstrate it in real life with 4 pilots in 4 different countries. By demonstrating these solutions, we hope to be able to persuade people to use them in the future. So the next steps, as I said, we are relatively early in the project. We've just started the first phase of piloting, which is still with more or less with friendly users, as most of the projects are doing. Especially the first phase is critical because systems are not that stable. So real pilot users could quit the project very easily. So we do it in the first phase, typically we do it in the first phase with 20 users, and then in second or third phases, we do it with actual users recruited from distribution operators. Then the second step is once we finish the first phase, which will be in a few months, we are incorporating the feedback from these results from first phase to develop the final prototype of the system, and then do the final validation on large scale. And also, one important aspect is also to elaborate some guidelines or best practices on how to do the replication of this system whenever you read it. So kind of a user manual. So this is more or less it. Thank you very much for your attention.
I think that the independent project is the sister project of STAND project. Has that been?
I'm not sure. I think we are in touch with Lord because we promised to do some at least investigate the potential cross-project replication, and we are actually doing one. And the sister projects are GLocalFlex, Reflex, and OpenUnity. So I don't think STAND is from the same call.
STAND, yeah, it's the same call.
STAND is from the same call.
Yeah, because we also talked to Luis
You talk to Luis, yeah.
Independent.
In the meanwhile, Raymond, you can be here.
Oh, sorry, I mixed it up. It's the previous project, Resonance, yeah. Probably from the same code.
Yeah, it's the same code.
Yeah, I'm mixing up because there are similar projects.
We're also in the same cluster, energy nexus cluster.
Yeah.
Just 2 minutes
So
for you.
I do like
you'll have to bear with me a bit more.
I almost forgot I had this. At some point I thought I had to do Fedecom, then you were doing Fedecom, and I completely erased it from my mind. I forgot about Interpret, which is my project, my coordinated project. Sorry.
I have the same problem. I just mixed up the projects.
So it's just too many things. So, and you can see that in the slides. I mean, it's a bit less elaborated, but in Interpret, the details of the Interpret project, you can find it online if you want to look at them. But basically, we are a project on positive energy districts, okay, which is halfway through. We have 14 partners, and what we are trying to do is very, very technical things for interoperability of different energy systems. The part I'm gonna tell you about is the marketplace part, which is based on a small simulation that the marketplace partner is Singularity, same of Fedecom, surprise, surprise, that they did a simulation in one of our pilots, and we can show what a marketplace could do in comparison with a normal optimization. Okay, that's gonna be pseudo-implemented because no regulation really allows you to do actual peer-to-peer to date. This doesn't happen. We have been discussing this for forever, but at least we can keep telling regulators this could be done if you only allow us to do it or get your head together and your wheels together for us to be able to implement what we have been studying in European projects for 7 years, actually. So yes, well, this is the nice image of the project with everything that we're gonna do, everything that we promise is in there. So it is many things, as every European project. This is a bit of in the Grid Singularity platform. You can set up the projects in a simulation environment. It's free. Everyone can get in. I don't work for Grid Singularity, but it's an tool anyway. So this is the Finchorn Eco Village, which is in the north part of Scotland. And if it's summertime, I recommend you to go there. If it's wintertime, don't go there. Lovely place. It's very peculiar as a pilot because they are kind of a old hippie community converted literal hippie community. They started with a van and 4 people living there, and they have grown to be over 600 people, hundreds of dwellings, and they are really a community that it's open for everyone to live there, but for you to live there, you kind of have to be on the vibe of the community. So you have to be a bit spiritual, you have to partake in the community things, etc., etc. The good thing, the social part there is amazing. So if you go tomorrow to my talk, I'll tell you everything about the social elements that we have done in the project there because people is super motivated. The bad part is not replicable. The things that they do, the months that they manage all the resources, the land, the grid, they have a big wind turbines, everything they can manage themselves. So it's very, very, very peculiar. In any case, in this thing called Eco Village, which by the way, Eco Village this exists across the world. You can find Eco Village, there is a group, and there's similar-minded type of villages that are around the world. Basically, we have several areas in the Eco Village that we are testing because, like any urban development, it goes by areas and spaces. And then each one of them we set up, so most of them they will have heat pumps, PVs for sure, a monitor load, and then battery storage in some of them. So basically that's what we're working with. The finding that we are finding is basically they just let their nice algorithms run, okay? And then we were working, what would we improve if we were to implement the market and market vision against a normal optimization and against no optimization at all, okay? And basically what they say for the period that they ran, 7 days, I know, don't ask me about it, they did it this way.
That's it. But at least we can see some cost savings that they say you reach 24%. That doesn't mean that the full year is going to be 24%, but there you can achieve cost saving in certain times, okay? We have a good increase in self-sufficiency, and this is very, very important and one of the results that we want to see in our project, because if we want to go for positive energy districts, we need to first be self-sufficient. We need to consume almost everything that we produce on site, otherwise there is no positive energy district to be had. Another aspect that we did is we were able by combining the heat pumps with geothermal heat pumps. Also, they have a wastewater treatment plant and doing a bit of change there. We were able to improve or to use energy and waste heat recuperation, and we use that by increasing the heat pump COP. So basically, we made the heat pumps more efficient by recovering heat from a waste source. Okay, this is very normal, but it's part of the project. And at the end, what we can see is that when this actually gets activated, there is way less imported energy from the grid. Okay, and we're actually starting to export energy to the grid, whether before we wouldn't export almost any energy to the grid. So that was the part that we want to show. Of course, we are still in the early phases of the project. This will be studied at length at some point, but at the moment, this is what we have. The next step is to make this a reality there, to show again that this can happen. They can do it. I mean, technically, it can be done. We need to demonstrate in the other pilots, and the pilots we have residential, but we also have purely commercial buildings type of pilot, which is a completely different monster. We don't deal with the final users, we deal with the administrators of the building, which it's very, very tricky. And then we want to replicate to other districts. If someone has a district that wants to become a follower, we are looking for followers. So send me an email and we will be happy to talk, which is basically trying to see how we can adopt there with a focus of positive energy district. As I say, the main work for Interpret goes into ICT and different standards for things. So here I'm trying just to show a little study that we have done to show that the market will have a positive impact. That was the idea, which we are not, that's why we're here. But I think we need to fight a lot for that to be enabled at regulatory level. That's, I think, it's it for me. Yeah.
Okay, so I think I'm the last one to talk. I'm Ana Garcia. I'm the project coordinator of EBUSCO. EBUSCO is a live project that is based on demonstrating how collaboration strategies among companies can increase the penetration of renewable sources, and it's based on the Energy Cooperation Hub concept that we more or less designed during the proposal phase. So the idea of these energy cooperation hubs is to establish some cooperation agreements in order to share energy assets and share storage, share generation, and share also flexibility and demand. Taking into account that in each country there are totally different market and regulatory contexts, and that each of the energy cooperation hub is very different. In Spain, we are focusing on an agricultural cooperative. In Greece, is more focused on retailing, and in Italy, is more focused on textile industry. So very different pilots. We are developing. We are not developing the tools because the tools already exist. We have in EBUSCO in this solution 3 digital tools. One is for energy sharing and management, the other one is flexibility tool, and the third one is the decision support tool. Each of the tools are from one of the partners in the consortium, and the challenge is to adapt these tools to the peculiarities of each of the demonstrators. And we will develop some services specific to each energy cooperation hub in order to share all these resources. Okay, so focusing on these three pillars of energy communities or energy cooperation hubs, as we conceptualize these communities. Regarding the optimization and activation, we need to find what is the complementarity of the businesses and the loads in order to define a baseline that this makes sense and allow us to calculate the energy cost reduction. Another challenge is also how to manage these share energy assets and how to manage this collective PV storage and flexibility that will be tested in the three countries with very different market regulations. So regarding the market participation, it's very for us it's very challenging also to how to design this business collaboration between different companies that are in their own businesses, and how to establish the remuneration schemes that are like fair for all the stakeholders' requirements. And finally, regarding the digital and physical infrastructure, as I already said, we have 3 digital tools, and the main challenge here is to adapt these tools to the context of each energy cooperation hub, and being also working also with the energy, the IoT infrastructure that is already developed there or deployed there. Well, I think I've not say that, but we have just started the project, so there is no really results and key findings, but at the same time we were working with this topic for several years, and even with the Spanish pilot we already have done some testing and some demonstration. So these results are mainly focused on this pilot. Regarding the optimization, we are doing just now 5-minute monitoring of the loads. We are also we have also deployed there some forecasting model for next day activation planning. There are only activation that last 1 hour. This 1 hour is because there are storage freeze chambers that can be only activated 1 hour in order not to damage the products. And we are working on changing this operational set point of the chambers, of the storage chambers, to reduce the energy consumption. Regarding the market participation, we have achieved from 5 to 15% cost savings using the market indexed prices that they have. Also in Spain, it's possible to, it's gonna be possible in next month, hopefully, to participate in ancillary services through aggregation in a service that is specific from Spain, that is the active demand response service. And also we there is not we are working on the remuneration and penalization schemes. Okay, and regarding the digital and physical infrastructure, as I already said, there are 3 different levels of development for each pilot. So the tools should adapt to the context of each pilot. In Spain, we, as I already said, we already have dynamic prices and some flexibility services in which the businesses can participate. In Italy, they are starting to develop and test these local flexibility markets, in which also these businesses can participate. And in Greece, they have a challenge in the changing from the net metering of the last year to the net billing that is going to start very soon. Last,
But not least.
What are our expected impact, because we don't have impacts just now, is to reach optimize self-consumption and flexibility, and increase this investment on renewables through the collective PV and storage, because in some cases one company cannot install more PV because the roof is totally full of PV, and there is another company that wants to install PV, but they are high seasonality of their demand, so they the numbers there is not profitable. So the idea here is to merge together in an energy cooperation hub and install the PV where it can be installed and share this generation. So this is in the second pillar. We need to define how this cooperation or this collaboration between the different businesses will work. So we will need to design this cooperation and also the fair remuneration and schemes. And finally, regarding the digital and physical infrastructure, our expected impact is to have a solution that is replicable, adaptive, and scalable for each energy cooperation hub and different regulations, sector, type of loads, etc., etc. And our next steps, we are very early in the project, but our first step is to establish these energy cooperation agreements and start working with the businesses in dealing with their interests, and their expectation in the project. That's all. Thank you.
Thank you so much for being in time, Anna. So we are 2 minutes before the official closure. And since Zia was unveiling the trick, we prepared also some questions, just in case. And among the questions that you provided me, maybe one could be answered because we didn't address the topic that has been proposed by Raymond. And so I can tell the question: do peer-to-peer really have an impact? So this is a very straightforward question that I propose to you, but also to the audience.
In Scandinavian countries only, I think. Peer-to-peer, me, I'm in the Greek energy market and expert there. Flexibility, peer-to-peer market, it's all under the legislation. I don't know what's happening in Spain. I am collaborating with the Spanish partner, but we don't have smart meters. It is obvious, me coming from the energy sector, if you don't, Kelvin told, if you don't measure, you cannot improve. Okay, so, first we need to push European Union, to push all the countries to have the same terminology. I heard a lot of things. You were telling the same thing with another terminology. We have net billing, net metering. If I tell to my Spanish gang net billing, I need to explain. So now that we are all together, first of all, before going to the peer-to-peer that is not working, only in Norway, Scandinavia, for sure, I saw there, I saw markets, and there are trading platforms, I saw a lot of things happening. First, let's all together standardize the terminology and to be on the same direction.
But why is that not possible? They're doing it with the EPBD for buildings, they're enforcing certain things for the performance of the building. But why for energy is it impossible?
It is not impossible, it's possible.
I mean,
to give the direction with the same terminology.
May I provide an answer?
The
Maybe
governments,
Okay. In the construction, they are like, okay, big companies, but they are not work together. In the energy, you have the DSO. They are really large. They manage all the system, and they are not that open to change. So I think that's one of the main issues. And also, as a government, you don't want to, mess up too much with them.
Right, because they're public.
No, it
It's
depends
just
a lot
about-
of how you do it. If you do it like in Spain, where you are basically taking business out of the DSO because you are forcing them to just not
to lose money.
to lose money, it's not gonna work. So you have to have all the stakeholders on board and reach a medium. You are not gonna reach the optimal for the final user or the optimal for the DSO. You need to reach a minimum. And also the question is around peer-to-peer. Is it really good for if I sell to my neighbor, or is it better if energy communities focus on peer-to-market, and then we have like in Fedecon federations that are doing the peer-to-peer, but it's between two big entities that have an impact on the grid, not so much as the headache that is setting up everything in the system with dispensing for me to sell 1 kilowatt to Paco in the next room. So
But for me, it would be, okay, if you could somehow just see the energy community as one consumer
And producer.
and producer, I mean, then,
Consumer.
okay, then all the participants in the community could do this peer-to-peer because it would be under the, the management of the energy community. So it
Like
would be,
self-consumption, like local control.
yeah, but in
Local
these cases, like for instance, in Spain, the collective PV plants that we can share PV plant works like a small individuals PV plant.
Yeah.
So you are not really sharing peer-to-peer, but you have this energy community, and you could work like a one, a client for the DSO. Then the energy community could really work with the peer-to-peer, local energy market, all this
you
stuff.
can do whatever you want. Yeah. But that's
The whole point is, if you have an energy community, you have to work, I mean, if you want to reap the benefits of peer-to-peer, you have to organize the energy community as a microgrid. Okay, so that as much as possible is optimized within, and what remains is then fed or sourced from the grid. And this is also beneficial in light of the volatility of renewable resources. It's beneficial for the grid because you have very local productions because they are now dispersed, and then you have a lot of flows of energy back and forth, which burdens the grid more than usual.
Yeah, but that is true, and I will buy that for big consumers in general. For small consumers, we have to run the maths, and you don't have a return on investment only on the infrastructure that you have to install for activating the heat pump, the individual heat pump, and metering, the electricity and the temperature. So that's what I say for the small consumer, the actual persons that wants to sell 1 kilowatt hour to the next, it's not that good. Maybe we can do something aggregate them. We first aggregate them and we treat them as an aggregated entity. Because, yeah, in theory, yes. In theory, if you have unlimited capex and you don't mind about the return of investment, for sure. But when we go to reality,
So it just cost benefits rate.
the numbers don't add up. There is no way, no one wants to put it in because
I mean, we had a similar experience in one of the past projects almost 10 years ago. We were hoping for huge benefits from reaping the flexibility of residential users already there then. And we were a bit disappointed with the numbers, the actual numbers.
we forget.
But, yeah,
we used to
because
forget the installation cost.
Not the numbers for the other stakeholders, but for the benefits for the actual consumers, because they were so small that
Marginal.
and people have to invest a lot of let's say behavioral changes in order to reap that small benefit. So it's,
If we could use more the smart meters that they are installed everywhere, and if we could
Everywhere in Spain.
Everywhere in Spain.
well, sorry, yes, everywhere in Spain, in Ireland, in several countries, sorry, in several countries there are. True. But if we could use it more, then
but also the question is whether 15 minutes measurements are okay for
or they
real-time
can do
control.
way
real-time
lower
control.
than 15 minutes. That's not the problem. At least in
Yeah.
Spain, they can.
Yeah.
I mean, if you want to real-time control, 15 minutes is not okay.
No.
And majority
You
of
have to do
installed
7
smart meters are 15 minutes measurements. The newest ones, Slovenia was a good pupil, I would say, because there was a directive, European directive, that 80% of consumers would be equipped with smart meters by 2020 across Europe. Okay, we reached that goal, but we cannot reap the benefits of that.
Because you don't see the measurements, and you don't see anything.
Costa?
Costa?
Okay, very short. So, I understand your point totally. So, what to do with my household 1 kilowatt hour that I have more, okay, to give. So, there it is the pool system, virtual. Imagine 1,000 houses to give there to the pool system 1 kilowatt hour. Pool system means either storage, either cash flow, aggregator. So there you start making the aggregator the most probable solution. You start making large-scale models because of the 1 kilowatt hour of 1,000. So there you need to start thinking not like a community, but like a government. So we go again to the market design on behalf of the TSO. Or this is again, we make the same circle. Someone to buy all of this energy and me as a single consumer that I give every day maybe 1 kilowatt hour to receive something back. So there, or to give me all the, if the model financially is sold, to give me all the installation cost, everything for free. Like they give me one mobile phone, who can make the calls, who can spend the day.